I don't find it necessary to explain to you why you need to maneuver for hurricanes. Just know that you do. Um, it's complicated. Based on how far away it is and your situation. If you're like more than 300 miles away from a hurricane when it's reported to you and it's like headed towards you, it's not that big a deal. Just go in another direction. It could be moving faster than you, so don't just go away from it. It might still catch up on you, but like just depart from the area. Potentially head into the ocean basin, and you should be fine. Or you could head into port if you've got a protected harbor. If you're closer, though, you're going to have to be more precise in your actions. And if you're inside the hurricane, at that point, you're just in harm reduction mode. You just have to plan out like what you can do to make it cause as little harm to the ship as possible. So there's different steps to take at those different stages. Again, when they're furthest away, you just go away. You don't need to do that much planning for it. When it's in that medium range where like you're going to end up in the storm, but you might not necessarily end up in the worst parts of the storm. Your best bet is to perform a hurricane plot on a moboard to maneuver in an ideal strategy away from it. And then once you're in the hurricane, that's a different, you shouldn't have gotten to that point. But if you are, then what you need to do is based on the concept of the dangerous semicircle and the less dangerous semicircle. And to understand that, you need to understand the anatomy of not just hurricanes, cyclones, or tropical storms in general, because they have different names depending on where they are. It's only a hurricane if you're in the North Atlantic. It's a monsoon in the Western Pacific. They've got some weird names for them monsoons in the Indian Ocean, typhoons in the Western Pacific, Northwestern Pacific, because in the Southwestern Pacific by Australia, they've got some really weird names. I forget exactly what they are. And then there's a couple different ones. I think they're anticyclones in the Southern Atlantic. They're all the same type of storm. It's just they have different names. And what you have to remember about them is that they're fundamentally moving in accordance with the Coriolis effect. I haven't done any meteorology videos yet, and I don't plan to, but I assume if you've had, maybe not even in your meteorology classes, maybe in TNAV, the explanation on why the Coriolis effect bends winds to the west, whether you're in the north or the south, based on the rotation of the earth, all the winds get thrown off towards the west. And what this does is it creates large cyclical wind patterns on like ocean basins where the winds get bent to the west from the eastern side of the ocean basin, whether that be the Atlantic or the Pacific or whatever. And then once it reaches the other side of the ocean basin, they actually end up getting bent back northwards to complete the cycle. And that's why you've got what they're called or oceanic gyres are the current portion of it, but the wind portion, I don't know if that also counts as gyres. Anyway, what it means is if you draw a really basic map of the earth, there's the Americas, there's Europe and Africa, and then here's Asia and Australia. What you're going to have is an ocean gyre in the North Atlantic rotating like that, clockwise, an ocean gyre in the South Atlantic rotating like that, counterclockwise, and then you'll have the same in the Pacific, the South Pacific, and then I didn't make room for it, but on the Indian Ocean, it's also rotating in the counterclockwise direction because the Indian Ocean is mostly in the southern hemisphere. And so Tropical storms, tropical cyclones, hurricanes, whatever you want to call them, get formed in and around the equator on the eastern side of whatever these ocean basins, wherever they might be. And they, due to the direction of the prevailing winds here, get pushed off to the west, which is why the western coasts of continents have to deal with this, whereas the eastern coasts don't. You don't really ever hear about hurricanes hitting Africa or the east coast of Africa or California, except for that one that did recently, but I think it skipped over Mexico. They almost always go to the west and hit the eastern coasts of the continents. So you could imagine a hurricane forming like there or there, and they will usually get sent across the ocean. They pick up speed as long as they're over warm water, and then get bent upwards towards the continents, which is why in America they always hit either, I didn't really make room for Florida, Louisiana, or up the east coast, and they're always strongest on the southern parts of the country that they hit. And of course also the Caribbean. They're doing the same everywhere. They're always going west and then getting redirected either north or south based on which side of the equator, not the equator, but the intracoastal convergence or intratropic convergence zone, which is the meteorological equivalent of the equator. Now, the other thing about these storms is that even though they rotate or they move according to these clockwise gyres in the north and counterclockwise in the south, they actually rotate within themselves in the opposite direction. So a hurricane, while it's moving along the ocean basin clockwise, it's actually rotating counterclockwise. And then in the south, it's rotating clockwise. Same over here. This is also due to the way the Coriolis effect operates within a low pressure system, because hurricanes are low pressure systems. All of that is to say, in summary, a storm moves west, or these tropical storms move west before slowly getting moved towards the poles after having started in the equatorial regions, and they rotate either clockwise or counterclockwise in the north or clockwise in the south. The reason that's important is because if we zoom in on one of these storms, and let's say we're in the north, that's its track like that. You can imagine here's the major basin of the Atlantic, and then here's over in the Caribbean and stuff. It's starting off westward and then heading up towards the north. And it is rotating like that along the way. Well, I say it's moving like it's a single object, but it's not a single object. It's a collection. It's, just a wind formation, meaning in all these situations, just wind moving one way or another. So if we think about the vector addition of these different wind vectors, right here at the very front of the hurricane, of the storm, you've got the rotational force sending it that way, but then you've got the lateral force of the entire storm moving, sending the wind that way. So the two combine to more or less have wind that's pointing, in truth, in that direction. In this case, you've got the rotational force sending the wind that way, and the lateral force sending the wind that way. So those two combine to have wind that goes that way, obviously. However, that's neither of that is really impressive. What's important, though, is here and here, because you've got here rotational force sending the wind that way, and lateral force sending the wind that way, meaning these two vectors almost cancel out. Now, I think the rotational force is ultimately stronger, so it's mostly the wind is going to be going this way, but not as strong as the rest of the storm. If we come over here, rotational force is going that way, and lateral force is going that way, meaning the total force of the wind is substantially stronger. And what this means is that for a hurricane in the North Atlantic, on the early part of its journey, the northern half of the storm, this half here, has the strongest winds, the strongest total winds, because you can see how strong this is right here compared to this much smaller vector. Remember, though, it's not the northern half, it's actually the right side of the track, because as this storm moves, once it gets to over here, the same vectors are true. This is two vectors going the same direction. This is two vectors going in opposite direction. And this is a vector going this way, a vector going this way, that way, and that way. So that means that this side is still the stronger, has the strongest winds. Anytime you're in the northern hemisphere, the right side of the track is where the strongest winds on a hurricane are. In the southern hemisphere, because they're rotating the opposite direction, it's always the left side of the track. Basically, if I draw this out here a few more times, what that means is that for all these storms in the north, here's the strong side, here's the strong side, here's the strong side. And when it gets up here, here's the strong side, here's the strong side. It's always the right side of the track. In the south, I don't know how far these storms go in the south. I don't know much about weather in South America. The strong side is always on the left side of the track. It doesn't matter which way the track is pointing, it's always on the left side in the south or the right side in the north. If you want to think about, make it even simpler, the strong side, which is the dangerous semicircle, is always pointing towards the center of the oceanic gyre. Whether it's in the north or the south, the dangerous semicircle is always the one nearer to the center of the ocean basin. You can see right there. In the north, the nearer to the center of the ocean basin will be on the right side. In the south, it'll be on the left side. This is all true for the Pacific as well, though the Pacific, well, I won't say that. The Pacific does have extremely strong typhoons over here, though because it's so much larger, they kind of build up for a longer period of time, meaning for the majority of the tropical zone of the Pacific, you don't really think about them. It's only when it hits the west coast of, or the east coast of Asia and Australia and Indonesia. All of the point of this is when you are close enough to a storm that you're going to hit it, whether you hit it, you just get into like the outer regions of it, or you're like gonna be in the storm itself. You want to be aware of where the dangerous semicircle is going to be and where the less dangerous semicircle is going to be, because this side of the storm is not good. This vector looks small, but you're still dealing with hurricane force winds, so it's still really bad. It's just not the worst it could possibly be. So your goal, if you're far enough away, is just to maneuver generally towards the south, or just book it away, being informed of its direction. If you're going to be entering the storm, your goal is to get to the less dangerous semicircle, if getting away is not an option. Now, to generalize what you should do if you are entering a storm, let's set up a storm again. Say it's going this way. Here's the rotation. If you get confused on which ways the storms rotate in the north and the south, the way I always think about it is the hurricanes in the north are running forward, throwing a right hook, which is why the wind is coming forward on the right side and why that's the dangerous semicircle. Whereas in the south, they're running forward, throwing a left hook. So you want to get away from the left side down there and the right side up here. Let's say your ship So we'll shade this in because it's the dangerous semicircle. In the situation where your ship finds itself entering into a storm, you could either be in the dangerous or the less dangerous semicircle. What you want to do in the dangerous semicircle is align yourself to have the wind hitting you on your starboard bow. What that's going to do is it's going to align you to head out, if not bank around through as best you can. If you're over here, the wind is on the starboard bow that way, meaning you'd be headed out this way. If you're over here, wind is on the starboard bow there, meaning you're going to head out that way. So putting the wind on the starboard bow when you're in the dangerous semicircle is going to generally just shoot you away in a direction tangent to the storm itself, so you can get out as fast as possible. In the less dangerous semicircle, you want to put it on the starboard quarter, and that will line you up to get out of the storm. Like so. This is not to mean that you're going to not have problems. If you line yourself up like this, you're going to be taking on, hurricane level winds and seas and all that. But this is not to minimize roll. This is to minimize the time you're going to spend inside the storm by aiming yourself as best you can out of it. Bear in mind, in the south, this is all reversed. In the south, you put everything on... Oh, wait, sorry, not the... I drew that on the port quarter. However, the wind would be coming more like that in accordance with the direction of the storm. So that would be starboard quarter to shoot you away. If you were in the south and you were entered into an anticyclone, so the southern version of a hurricane, you would put everything on your port bow and your port quarter and would have the same effect of getting you angled out of the storm. But that's a last resort. That's if you're in it. If you're in it as bad as it's going to be, this is how you minimize the harm. If you're far enough away, you just turn away. And the middle range where you're going to enter the storm, but you're not so screwed that you're in this situation, is when you use a motorboard, and we'll get into that in the next video.